Hello and welcome lads and lasses to another video. My name is Tamit Chowdhury, aka Dr. Chowdhury, the only doctor without a PhD. Today this video is all about atoms and elements. Sit back, don't relax, as we are jumping right into the video. Hello guys and welcome to another video. This video is on about chemistry, maybe next video might be on physics or maths, who knows. And in this video we're going to talk about atoms and elements. Alright, firstly, we need to go through what an atom is. Atoms are the smallest things that make up an element or a substance. They have a radius of 0.1 nanometers, which is the same as saying 0.00000000001 meters. That's pretty small. Alright, so what does an atom contain? It contains a nucleus that is surrounded by electrons that orbit around the nucleus. These electrons orbit around a fixed distance, as proven by Niels Bohr, a scientist that was involved in the history of the atom. Now, in the nucleus, it contains protons and neutrons. Protons have a relative mass of 1 and a charge of +1. It also contains neutrons, which have a relative mass of 1 as well, but has no charge. It's a neutron, hence the name neutrons. Now, that's what's in the nucleus. Surrounding the nucleus are negative charge electrons, which basically has virtually no mass, if I can put it in latent terms. Now, the whole mass of an atom is concentrated near the nucleus because of the relative mass of protons and neutrons being 1. Electrons virtually have no mass, so most of the mass is concentrated in the nucleus. Also, a nucleus has a radius of 1 × 10⁻⁻14 meters. Now, talking about the orbit of the electrons, they take up a lot of space, and the volume of the orbit depends on the size of the atom. Now, in atoms, they all have a neutral charge. This is because the number of protons equals to the number of electrons, so the charges just cancel out. Unless it's an ion where there's more electrons or there's more protons, then that's where an atom becomes an actual positive charge and an actual negative charge. But that's going to come up in a later video. I'm sure most of you saw a periodic table. You see 2 letters or 1 letter next to 2 sets of numbers. So let's take an example of carbon. Carbon has the chemical symbol of C, and on the C it has a 12 on top or a 6 on the bottom. Now, this 12 and 6 can be swapped around, but one thing to remember is that the biggest number is the atomic mass, and the smallest number is the number of protons, or the atomic number. Now, one thing to take notice here, as I said, number of protons equals to a number of electrons. If a question asks you how many electrons carbon has, just look at the atomic number, the number of protons. And since the number of protons equals to the number of electrons, this carbon will have 6 electrons. Now, the atomic mass is essentially the number of protons and neutrons added together. So if you want to find the number of neutrons in this element, you do 12 minus 6 and you get 6 neutrons. Now, there's lots of atoms, as you can tell, but what determines an atom is the number of protons it has. So we can lead on to elements. Elements is a substance that contains one type of atom that has the same number of protons throughout. So if you look at the element carbon, carbon has all the atoms only contains 6 protons. So that's what makes it an element. So for example, helium as well, the atoms contains 2 protons, and there's a bunch of those atoms, so it makes it a helium element. One thing to consider as well, there's about 100 different elements on the periodic table. Now, as I've shown on the board, these elements can be represented by a symbol like carbon for C, sodium for Na, iron for Fe, so on and so on. How do they get these letters? It's because most of these names originate from Latin. Now, something with elements and atoms with that, they can come in range of isotopes as well. An isotope is basically an element with a different atomic mass than its original. So again, let's take carbon 12 for example. When I say carbon 12, the number is basically the atomic mass. So let's do C12 and 6. That's the original element. Now, the isotope of this carbon, for example, would be carbon 13. It will still have the same number of protons but a different number of neutrons. Now, you might be wondering, how do they get these atomic mass numbers? Well, there's a formula for relative atomic mass, which includes the sum of isotope abundance times the isotope mass number divided by the abundance added together. So let's give an example. Now, these values behind me, they've been taken from the CGP chemistry revision guide, and what the question will be here is calculate the relative atomic mass to one decimal point using these values. So following the formula, if let me just write the formula down. AR literally means relative atomic mass is equal to sum of isotope abundance multiplied by the isotope mass number, which is essentially this, divided by sum of the abundance of the isotopes. Now, how would you use this formula? So we got the isotope mass number and we got the abundance, and it says sum of isotope abundance times isotope mass number. I'm just going to rub this out really quickly because I don't have that much space to write it with. The relative atomic mass will be the sum of 63, the mass number, times the abundance, which is 63 times 69.2, plus the next one, 65 times 30.8, divided by the abundance added together, 69.2 plus 30.8, which is equal to essentially 63.6. And if you look on the periodic table, the mass number is 63.5, but it's because we only got two values right here, so it does become a bit, but it's near enough the same essentially. And that's the end of the video, guys. Quick summary: atoms contain a nucleus and electrons surrounding the nucleus. Nucleus being made of protons and neutrons. Atom has a neutral charge because the number of protons equals to the number of electrons. They cancel out. Elements are a substance made of one type of atom, which there's loads of. And then what distinguishes an atom is the number of protons it has. And also there's isotopes, which are essentially atoms with different number of neutrons as well. Thank you guys for watching, and I'll see you next time. Yes. Go away. Go away.